Hello, and welcome to Thinking Like an Engineer, Episode 1. In the last episode, we went over the creation of an app that I'm using personally to monitor the blood sugar readings from my wife's Dexcom and then get text messages about them in case the app notifications fail. And I've been using this for about a week or week and a half now, and it's working, which is the first awesome thing. And secondly, it has actually jumped in and helped notify me of certain things that the app didn't. So mission accomplished there. So I could call this a success, but after that week or 10 days of tests, I've learned a few things about how I want to improve this and make it work even better for me. And so I'm actually going to be making those changes here in the next few episodes and show you what that's like. So before I go too far into writing the code, I want to talk about what refactoring is and why you might do it. Because it's something you often hear thrown around, but especially if you're new, it's something that may not make sense as why you're doing this rather than adding features. And the reason is you refactor existing code, you take code that's already working, and you rewrite it in a way that removes some limitation. So a good example would be you have code that's very slow and you want it to produce the same output, you just want it to run faster. That's a very common reason for refactoring. I would say one of the most common reasons, actually. It's not one we're going to work with today. There's about 4 or 5 other things that will refactor, and I'll talk about why you might do that just in general. But that would be a very good reason to do so. For me, I'm not just refactoring it for the sake of rewriting this. It does what it needs, but I need this to do something more soon. I've got a bunch of ideas planned, and it's going to be a lot easier once we work on these things. So the first limitation I'm going to work on in this app is when this should send me a message. So right now, this is hard-coded to a case of if the blood sugar value is less than or equal to 80. And that worked, but didn't capture every event that I wanted an alert for. An example would be my wife was out exercising and her blood sugar was still above 80, but it was dropping very rapidly. And in those cases, it's much better to know that it's dropping earlier so that I can then say, hey, you should drink some Gatorade or something, rather than wait until it's dropping, until that this measurement shows it's below 80, because usually by the time this happens, it's actually below that and still dropping. So it's just better for me to know this earlier. So the way this is set up, I'm limited to, just this value. And I could throw in a whole bunch of, ors to, alternative cases. But I think the more long-term way of approaching this would be making a function that takes in, whatever parameters I need to make a decision, and then outputs true or false whether I should send that value. So I'm going to write a function, should send message. And I'm going to take in a Dexcom object in this case. So I'm going to return either true or false. I know that. But what am I going to look at? So firstly, I'm going to assume, I know that the BG value and the dex in this function are going to be synonymous. So I'm just going to write a whole bunch of ifs, and there may be a better way to do that, but that's another refactoring project. So if dex.value is less than or equal to 80, return true. Or I know that if the let's see, so it's the trend description. That's what I'm looking for. If dex.trend description is, I believe it's falling quickly, return true. I could do the same thing and say If it's rising quickly, that's actually a different sort of issue, but hey, could be something I want. I'll fix the syntax errors. Return true, and then default return false. So the basic idea here is look at all the values that I care to look at. If it matches one or more of these, return true. Otherwise, return false. And I know that if any of these evaluate as truthy, it's going to short circuit it. So, that should work. Oh, and I thought of one extra case. So if the value is less than or equal to 100 and the trend description is just falling, then also return true. So this gives me a couple of places where I can, I should say this function gives me a place to put all the different logic in here, and it will also make this much easier to read. So I say if should send message, then pass in that BG object, then this should now work. All right, I'm actually going to run this now, and with any luck, all right, so it says all is clear for now. I checked in the app, and my wife's blood sugar is 99 and steady, nearly a unicorn. And so because of that, I shouldn't get any message. Once we get to some of these other values, I'm excited to see if the rest of the logic worked. Fingers crossed it should, but I never trust my code that much. That's an example of making your code more flexible for other use cases or other changes. It did have that secondary benefit of what we're going to go into next, of making it more readable. So for this, you can see, having this one function, say, all right, should this send a message, versus having 4 or 5 different chained conditionals. That already just makes it much easier to read. Another example I'm going to do is regarding this string. So this is fine as is, but I know that there's other changes I'm going to want to make to messaging, and so I want to make this easier. So same thing, I'm going to add in a, let's say, build message body, and I'm going to take in another dexcom object, and then I'm going to return an F string, and something that, I don't play around in Python much, but I thought it was really cool that you can put a string or a bunch of F strings in here and it will concatenate them all in the end. So firstly, I could just move this up here, fix the indentation because we're in Python and that's required. But, that by itself, that should run. Yeah, so nothing changed there. But I want to, make this a little bit easier to read and a little bit easier to change in the future. So I'm going to do something like, blood sugar update. And then let's say I'll add a new line there, add another F string. Current reading is this. And then let's say I want to add a new line there. Make it another F string. Trend is this. And then let's just make it another new line. Reading taken at this time. All right. So then I'll actually print this out anyway, just to see, or just for the sake of making this easier to see. I'm going to put this in even if it doesn't run. And with any luck, we should see a neater string. Yeah, so current reading is 102, trend is steady, reading taken at this time, all is clear. So it didn't send a message, perfect. All right, so this is great. I could keep tweaking this, as much as I want, but one thing you can see here is it's much easier. If I'm looking at what's the logic, it's much easier to have this than trying to build out the string in here. Another benefit is if you're looking at like a history of a file in a diff, you can then see there's no changes to the logic in here necessarily in the future. Like I'm always from now on going to be using this function to build the string. So if I want to see if there's changes in the string logic, I look here and it doesn't, like I can make those changes and it's easier to review rather than, someone looking over the logic of the entire app itself or the entire script itself. They can just focus on these changes, and it just makes it a little bit easier to read and helps with other people working on the same code. This next reason for refactoring probably sounds the weirdest out of all of them so far, but if you get past any unfamiliar vocabulary, I think things will start to make a little bit more sense then. But the reason for this one would be making code more idiomatic. And that's a really fancy way of saying making it seem like your code is native to the language that it's in. So like an idiom in any language, not just a programming language, is like a turn of phrase or something that has a particular meaning to a native speaker. So like if I said that managing developers is like herding cats, it doesn't mean that I literally bribe developers with catnip. It means that it's a difficult thing to do, sort of like herding cats would be. And that's very, something that would make sense to a native speaker. So every language has things like that. But there's also just ways of expressing things that are more, they fit more within the context of the language they're in, So there are certain ways that you're going to write code in Python it's going to be specific to Python because you're in that universe. Or for JavaScript, you're going to use object destructuring, which is very JavaScripty. So one of the reasons I bring this up is so that you'll often see things in code reviews and say like, hey, I know this works, but there's a better way to express that, whether that's like a built-in function or just a sort of programming paradigm or style that works within the language or framework you're working in. So really this one is pretty simple, and it's that right now everything is in just this one file, and sort of in you're running it as a script. But one of the common Python idioms is to create a main function because it doesn't necessarily have one by default the same way a lot of languages do. And then you have this semi-magical incantation of if name equals main, which is to say, and then run this function main. What this does is, prevents the file from running in unexpected ways if you're running it as a script rather than importing it somewhere. So this is just to make sure you don't run into any unexpected behavior or anything like that. So save this, run it, everything should work. I have some scoping issues I need to figure out there, but in general, everything should be the same. So this is actually a perfect example of why you set things up like this, is that I actually had a global variable BG that I was referencing here. And because of that, this code was working, but really I should be referencing this dex variable that I'm passing to the function. And so props to you if you caught that and I didn't, but this is another great reason is you get into all sorts of, scope issues, and it just helps avoid that. So usually there's good reasons for why you might do this, or, for, particular idioms, it may just be that it looks much neater. Like using a list comprehension in Python is probably going to save you several lines of code and versus using a for loop, for example. So there's usually good reasons for these. All right, and the last reason to refactor that I'm going to include in here is adding more visibility. So right now I am just printing out the output to the console, which works great for this. But let's say I am running running this code on a server like I actually have, and something happens, and it should send a message, but it doesn't, and I don't necessarily know why. Adding a logging tool is what will help me diagnose this, look at the error messages, look at the stack trace, see where things aired out, and help him fix those bugs and improve it. So what I'm going to do is add in the magic. This is going to look a little more magical. I'm just importing the logging as well as a rotating file handler, which lets you write to multiple files. So you've probably seen this if you've ever like looked at a server logs where it's like, apache.log, apache.log.1, etc. So this just enables a backlog in case I have way too many logs, and it helps make sure I don't lose them. So then I'm going to add in this other magical code written on another screen after consulting the Python docs, and maybe Stack Overflow to double check a couple things. But either way, I'm going to then say, all right, if after this happens, this should probably go further up and then go in here. So then I'm going to look at logging this either way. So logger dot, I think it's logger.log, and then example. So I'm going to figure out exactly what I want to output and then go from there. All right, so I went back and forth between the documentation, writing code, finding an error, then rewriting it. So, the pretty standard programming loop. Went through it somewhere between 2 and 22 times. I'll let you guess the actual number. But the result is that this is now working. So it is logger.info to set the level, or logger.error. There's some different ways you can call that, but that's what I did here. I put everything inside of a try except so that I would catch those exceptions and log them more successfully. And then, did some more fun configuration up here, but not a whole lot worth talking about. So the good news is we refactored this, and now we're in a very good place so that as we start adding some more features to this, then it will be much more maintainable. We won't have to rewrite stuff then. We've got everything set up the way we need it. So look forward to going over those changes in an upcoming video. And until then, happy coding.